Hello, my name is René Chutura. I present DruidJS, a JavaScript library for using and interacting with dimensionality reduction. First I will give an introduction, then I will show you a demo, and at last I will show you some of our evaluation results. Visualizations on the web are very popular and common nowadays, and dimensionality reduction is an important tool for dealing with high-dimensional data. There are plenty of DR methods and there exist some libraries bundling some of them. There is, for instance, scikit-learn for Python, dimret for R, and the R toolbox for MATLAB. Some JavaScript libraries exist, which implements one or two DR methods. For instance, MachineLearn.js, which implements PCA, t-SNE.js, UMAP.js, and MDS.js, which implements PCA and landmark MDS. To use a DR method, you had to use either a server-client architecture, use an already existing JavaScript implementation, or if no implementation of the specific DR method exists, implement the DR method by yourself. Users with sensitive data will have privacy concerns using a web tool relying on a server-client architecture. Existing JavaScript libraries have different interfaces, which needs lookup by the programmer for each DR method, and implementing a DR method in JavaScript is not an easy task and can be very time-consuming. Our JavaScript library DruidJS implements in the meantime 11 DR methods, is dependency-free, has a consistent interface, and is easy to use. For the demo, I prepared an observable notebook where I already imported the D3, DruidJS, and the iris dataset, which consists of 150 objects of 3 different kinds of flowers and has 4 different dimensions per object. I prepared a draw function, which takes the projection, creates a SVG, and draws the projection into the SVG. To project a data set with an DR method, you create an DR object, for instance PCA. As argument, you give the dataset, and then you transform it. I show you the result with the prepared draw function. And if you want to project the data with, for instance, MDS, you can change it here, for instance, to MDS or isomap or LSP or t-SNE. t-SNE is an iterative method where we implemented a generator function. The generator function returns an iterator which yields the intermediate results of the process, of the dimensionality reduction process. So let's create a generator. And iterate through. And draw the intermediate results. If you want to change the parameterization of the DR method, you can look up which parameters are available by looking into the variable parameter list. t-SNE has 2 parameters, perplexity and epsilon, which can be set in the constructor after the dataset. For instance, I want to change perplexity to 10 and epsilon to 1, which results in this view, in this projection. I also can use the parameter method, which takes as first argument the name of the parameter, as second argument the value. For instance, I want to set it to 2, which leads to a bad projection. Or I use the alias para and set the perplexity, for instance, to 100, which results in a better projection. Another dimensionality reduction method which is iterative is UMAP. For The generator method is much more important for bigger dataset sizes. We have, for instance, the fashion MNIST dataset, which consists of 766 objects of 10 different kinds of objects and has 784 different dimensions. You can see here the generator method, which already shows some results. If I want to show the final result by using the transform function, it would need much longer. The generator method starts much earlier. No. So now to the evaluation. We evaluated at DruidJS by comparing the runtimes of the Python implementations of scikit-learn and UMAP and the existing JavaScript libraries. Each row represents a tr method, each column a dataset length, and each line in the boxes for a dimensionality of the dataset. For each line, we show the 2 fastest libraries of the 5 runs per library, and stopped for higher dataset sizes if the run times exceeds 10 seconds. DruidJS comes out on the top for smaller dataset sizes, except for PCA, which is not that affected from high dataset sizes, but much more from high dimensionality. And for MDS, where DruidJS performed better than the scikit-learn implementation. More detailed figures can be found in the supplemental material as well as in the online demo. In the online demo, each dr method can be tested. For each dr method exists a table like this one, with rectangles defining a set of dataset size and dimensionality. By clicking on one of the rectangles, the site creates a random dataset of the respective set of dataset size and dimensionality and computes a projection in your browser. The result gets projected on the right with the respective runtime it needed. In conclusion, DruidJS offers an alternative to other libraries, which should lower the barrier to use dr methods in a web tool. Thank you very much. Here are some additional resources.